Welcome to Friday night's video and our second master series. I do believe that this is the 34th video in our second master series and the first video on dealing with impulse responses and frequency responses. So this is an introduction, but this short series is going to probably help you a lot. When I'll kind of give you some rundown of this. Like I always say, that most usage of most things is how you see things and how you want to get things done. Which some things you can do more or less, or use things to some degree that some things just sound bad. But I've heard some productions that stuff come out and I'm like, that does sounds horrible, and they just love it. So I'm real leery about telling people how to use something more than trying to inform them what they're looking at, so they can have a more informed decision, so that when they become this virtuoso master audio engineer, that whatever decisions they decide to do, that they knew what they were doing rather than them just fumbling around. That way, even if it's something funky or weird or psycho, that it was a decision they consciously made to make that sound. You know what I'm saying? As an engineer, as a master audio engineer. So we are going to talk about frequency responses, and impulse responses. Now, most of the time, most systems aren't set up with a frequency response meter and an impulse response meter because of the nature of it. Now, the problem is that impulse responses, we're using convolution reverbs and using reverberation and things like that, and things are just inherent in different VSTs or instruments, or when you're miking things and all kinds of aspects. Multiply sounds because of what's happening. So it can have good effects and bad effects to your production. So, and the problem is this whole subject can get really in depth. There's a couple videos on my channel talking about the C50 clarity guides, and there before the first master series, there's two of them on the C50 clarity guides and trying to shape impulse responses. And while you're shaping the impulse responses, you're shaping the frequency response and the impulse response whenever using convolution reverb. Those videos are going to help you a lot to understand just the concept of what frequency and impulse responses are doing. Now, the concept here is they're more than likely going to be in your production in one way or another, no matter what you do. Sometimes just in VSTs with patches that they've used, that it's inherent in there that it's not just a static dry sound. There is some reverberation in the sounds. It came from somewhere when they were recording things, when they were creating patches. And that's just like VST instruments. When you start recording things, or you start adding reverb, or you're doing spatialization, that all these things are going to affect the impulse and frequency response of the end product. What's involved in it, and what gets convolved, and what gets mathematically, how do I say, summed into the sound that you're done working on, that adds more stuff to it, that basically works out to not only convolving the sound and summing different things into the sound, but also convolving other mathematical properties that can be directly or indirectly related to affecting the frequency and impulse response. So this is a huge subject. And in this short series, we're going to kind of get into it, and more of a point of direction is I want you to read about that and study about it, so that you're a more informed audio engineer, to make you that quote unquote next level master audio engineer, because it's very involved. First of all, that you really want to understand reverberation, room acoustics, and things like that, and how that's directly related to some things, processing you may be doing, or, how you affect the audio, how that's going to affect things that are already inherently in it, which is a huge subject and is very difficult to pick apart sometimes with some of the equipment you have in a DAW, because it's very involved. So we're going to look at a couple things. First of all, that if you watch those two videos, it'll give you a pretty good understanding of direction. Now, once you understand that, we're using this most of the time for a couple of different reasons. We're using this to, analyze what's happening, like in a drum hit, whether it's coming from a VST or recorded or whatever, that there's impulse and frequency response properties that are happening there that you may want to, work with and edit and things like that to try to clean things up. Or you want to add spatialization to it, so understanding what you're looking at is very important so that you can make really informed decisions so that you become that next level audio engineer, doing things on purpose rather than things happening on accident. Accidents can cause messes. Sometimes accidents cause beautiful things to happen, and sometimes they just cause a mess. So it's a huge topic. Now, in your DAW, that you can actually look at impulse responses right in your DAW. You can drag an impulse response in there and analyze what's happening there from the beginning of the file through it. And you can edit it and all kinds of things once you kind of understand what's going on there. Now, what's happening there with the impulse response and the frequency response we'll get into. But just basically when we're dealing with the impulse response itself, now you can loop this impulse response and you can really, check it out and look at it, and you can one-shot it and evaluate it very well with your scope. You can one-shot this thing and very well evaluate is what's going on with this impulse response. Now, a lot of times you can see it's beginning here, and then this is the tail end of it off here before it repeats again. You can see it tail off right there, and then it's repeating. So you can see basically the whole waveform going across there. Now, the concept here is that they're very complicated. Now, whether or not you're going to pick them apart on a scope, which is basic meters you have in your DAW, or you're going to look at it at the spectrometer, that you're going to loop it and trying to figure out what the spectral content on there. Because either way, that whether or not you're looking at an impulse response here, you're going to see basically, the levels that are happening throughout the response, looking at a scope, or you're going to be looking actually the frequency levels and what the frequency content in there. I mean, a real simple example is this frequency content is going to get convolved using a convolution reverb onto whatever sound that you're doing. So this obviously is going to change the sound. The frequency content in this impulse response is going to change the sound of what you're working on. And in the time zone, that those reverberations and those levels are going to convolve onto the levels of whatever you're putting that impulse response onto. So you're going to change the sound in two ways with any impulse response, which sounds funny, but it's changing the sound in a lot of different ways, from what it was, which sounds the more you think about that, the more obvious that becomes, and the more that you start to think about impulse responses, reverberations, and things like that in a much more detailed way, and really want to understand them better. Now, those are just a couple things in your DAW, and also that if you can actually bounce impulse responses into stereo impulse responses also that are going to have a different effect, that you can actually evaluate them on like a phase meter to see what's happening there and cause all kinds of different effects by using stereo impulse responses, which is a whole nother in-depth topic which you probably haven't heard a whole lot about, and it's an experimental thing. Now, when we're taking a look at this, there's a couple other tools. Like there's a tool like REW here, which is a free tool. You can get all kinds of tools for evaluating this stuff, but this is going to show you the frequency response. It's going to show you the impulse response itself, what is happening with it. It's going to show you clarity issues, RT60 issues. It's going to show you tons of information about what all is involved in that impulse response or that frequency response. And you can also take like a drum hit or a vocalist going, hey, to test reverberations and your microphones, what it's convolving onto that sound and what the reverberations and all kinds of tons of information to help you make better decisions about what you're looking at. The spectrogram of it, what's involved in the spectrogram. Tons of information. Now, for me to sit here and go through everything this thing's, we'd have a ton of videos, bro. I'd be making videos on this subject for a long time. So I really suggest if you can't afford an expensive piece of software to evaluate this kind of stuff, REW, I really suggest you get this piece of software. It's free and you can donate something. Please donate to them. They're pretty cool and this is an awesome piece of software. And if you can afford it, otherwise they're trying to help, and and start reading about all the things that it's telling you, because it's going to greatly help you become that next level master audio engineer. And also, there's things like Sonic Visualizer. Sonic Visualizer that you can look at the impulse response here, and you can really zoom in to get some detailed information about all the way down the samples, what's going on with that individual impulse response, or any sound that has any type of reverberation on it. That a drum hit is a prime example. It's going to have impulse and frequency response information on it, convolved with it when you record it, to help you evaluate what's going on to it and to help you understand whether that's good or bad. And it's showing you the frequency content at any given moment after so many samples. There's a certain set of samples, and then the reading will change after it reads a certain amount of samples, if you can see that, and the frequency response is changing a little bit. And you can also look at it like in this kind of a view like this to better evaluate it. And also you can look at frequency impulse responses in something like RX, and RX can give you a ton of information about what's going on there. So the basic understanding, we're going to talk about it a little bit, but the biggest thing to understand about when we're going to look at a couple tools about frequency impulse response and understanding it, I really want you to get something like REW and really watch those videos I talked about and really read about that so you can really understand the information it's trying to tell you. We're going to talk about it some in a couple videos. We're not going to make a bunch of them because the basic concept's pretty simple. You're really dealing with impulse and frequency responses that you can shape. You're dealing with instruments that have that convolved into them in one way, shape, or form, that it's going to end up convolved. It's just like if I record my microphone here and you're hearing it, there's an impulse and frequency response convolved onto the sound that you're hearing right now. And in some cases that can be bad or good, depending on how you see it, what you're trying to do in the situation. So it can be kind of complicated. So what we're going to do is we're going to go ahead and take a look at impulse and frequency responses, some ways to look at them, and get a little bit better understanding of what we're looking at, so that this information can become, help take you to that next level audio engineer, because it affects your audio in a huge way. If you really read about convolution, reverb, and impulse responses and frequency responses, and it, in any situation, whether you're using an impulse response that's going to have a frequency response on it, it's going to get used in a convolution reverb, it's going to get printed onto the audio and summed into it, convolved onto it. If you're using a stock reverb or anything like that, it's going to do somewhat the same kind of thing, but in a little bit different way. If you're miking things, it will, just from the room. And the microphone itself has its own frequency and impulse response. There's a whole series on my channel about microphones, that the microphone itself is going to affect the frequency and impulse response as well as your room. Does that make sense? As well as possibly your audio interface, and anything else it's running to might affect the frequency impulse response, which is going to have a huge effect on whatever you're doing. Sometimes slightly, sometimes more than slightly, but you understand sometimes people will go out and spend bazillions of dollars on microphones, interfaces, hardware, software, all kinds of things trying to tame that lion. Does that make sense? Because it's going to affect your audio in one way or shape or form, no matter what you do. Whether you're using a VST, you're microphoning things, you're using reverberations, and any other types of effects, processing can affect that domain. And you wouldn't think so, but it does, and it gets mathematically involved and summed into the end product, the end audio file, which gets very in-depth. So the more you understand this topic, the better of an audio engineer you're going to be, because you're going to make really good decisions that are related to impulse responses, frequency responses, and basically this subject. So, peace, hope, love. I hope you enjoyed this introduction, and I will see you in the next video.